This example presents a case of calculating confidence interval for population proportion. So let's assume a construction engineer is to investigate cracked tiles on walls of large buildings. And there are in total 5 million tiles to be checked, out of which some part is cracked. An estimate is needed of how many new tiles have to be ordered to replace the broken ones. So the engineer does not have the time nor resources to check all of them, and he verified only a sample of that 1,250 tiles chosen randomly. And out of those, 89 are cracked. So the problem is, what is the 99% confidence interval out of the 5 million tiles to be replaced? So knowing how many he checked and knowing what proportion out of those are cracked, we would like to know what is that 99%. So with 99% confidence, how many we can say are cracked out of the 5 million. So in that case, we know the number of checked tiles was 1,250, and the cracked ones, which in our case is the success, is 98. And so that means that the proportion, the sample proportion, is the ratio 98 divided by 1,250, and that gives us 0.0784. So if we require a confidence level of 99%, then we use a critical value from normal distribution that is respective for 99%. Now we want the two-sided confidence interval, which means that we need the critical value which is respective for alpha over 2. So that means that 0.005, because that's 0.5%. And that one we can check quickly from MATLAB what value that would be. So we need norm inv, and we give our 0.005, we will get a negative one, but it doesn't matter, we just need that absolute value. It's the same as if we insert here 995. So it's 257.58. So that means that the confidence interval will be our proportion, which we know is 0.0784, and on the left hand side minus z alpha over 2 divided by n. I will use the representation with x and n, so x, n minus x, and all divided by n, and then the right hand side proportion plus the same thing, so z alpha over 2 n square root x times n minus x and divided by n. So this is our interval. When we plug the numbers in, you can check it for yourself, we get anything between 0.0588 and 0.0980. Of course, these are proportions, and we know that the total number of the tiles was 5 million. So now if we multiply these proportions by that, then the estimate for the cracked tiles would be anywhere between 294,000 on the left hand side and then 490,000 on the right hand side. So that's the answer. The engineer says that with 99% confidence, the number of tiles to be changed is anywhere between these two numbers.